try to decide or figure out which one of these two values is smaller. We have two fractions we're looking at. We have 34 over 50, and we have 3 over 5. Now, we could just grab a calculator, and we could divide 34 by 50 and 3 by 5 and get the equivalent decimals for those. And that's one option, and that does work. But I want to do something a little different. I want to look at this and use the fractions and do this just with what we have on hand here, without any type of calculators. Just multiply, divide, whatever we need to do in order to be able to compare these two fractions in such a way that we can determine which one's larger, which one's smaller. Those are the same question. It's just, which one you're picking is all you're doing there, right? So let's first look at what we can do with these two fractions. Now, some of this goes back to some other concepts that you need to have it at hand in order to deal with this. Primarily, we need to be able to reduce this fraction, or we need to be able to find equivalent versions of this and make it bigger. And there are lots of options we can do, so there's different directions. I'm going to start here in this. This is just one way we can do this, right? So I'm looking at this, and I'm thinking, I can do 34 divided by 2, and I can do 50 divided by 2. And that gives me 17 over 25. Well, that's still not over 5, so I still can't compare it. And just to reiterate this, we need to make sure that we understand we need the denominators here to be the same size to really accurately compare this, because the numerators are also different sizes. We can make an estimate maybe, and we get a feel for that, but we can't really compare these yet because we have 25 and we have 5, and since the parts are not the same size, we can't really compare the number of pieces and how they relate to each other. So we keep going, except 17's prime. I can't reduce 17 anymore. I did this on purpose because there was another option we could have gone with this, and I'll show you that one here in a moment. But this kind of points out that even when we reduce this, it doesn't always just end and be able to compare this. But what I can do is I can create this one and make it a equivalent fraction, which is what I did here. But instead of dividing like I did on the one on the left here, I'm going to multiply. So I can do 3 times 5 and 5 times 5. Well, why 5? Over here I divided by 2, so what's my purpose in multiplying by 5 over here on the other side? So you're like, well, did you pick any number you want to? Well, yeah, you can. I can do 4 over 4, I can do 6 over 6, I can do 12 over 12, I can do a million over a million. I can do any two numbers I want on top and bottom, or the numerator and the denominator, as long as I'm doing the same on both of those. But I'm going to pick one that strategically makes this problem more workable, makes it easier to deal with. And I recognize that I have 5 there, and if I do 5 times 5, I get 25. And then the denominator is going to match, right? So this denominator becomes 25, the numerator becomes 15, and now I can compare them. Now the parts are the same, so now I can compare the pieces. I see 17 is larger than 15, so that tells me that this is the larger one, and this is the smaller one, right? And there are different ways we can answer this, and we want to be clear about how we want to answer this. If I'm saying which one's smaller, 3/5 is smaller. If I'm asking us to compare the two fractions and determine their size comparisons, 17/25 is larger than 15/25. Is the same thing as saying, if I take out the or here and do that, that's correct. So that is another way to answer this. If I'm saying which one's larger, there it is. I did all 3 of those answers by doing the same exact process. Now there's another way we could have done this as well. So another thing I could have done is get another equivalent fraction over here. And I could have done 3 times 10 over 5 times 10, right? So if I do that, I have 30 over 50, and once again I can compare those. And 34 is larger than 30, so we still end up with that same spot at the end. These are just different ways to work with fractions. I'm also trying to demonstrate the idea behind equivalence of fractions. And again, you may be saying, well, where did 10 come from? I'm recognizing that 5 times 10 is 50. And I can multiply the denominator by anything I want to. And if I want to maintain the fraction to be equivalent, I just need to multiply the top by that same exact value. All right? I hope this was useful and helpful, and keep on doing math.